2.1. Describe Hertz's observation of the effect of radio wave on a receiver and the photoelectric effect he produced but failed to investigate. The discovery of the photoelectric effect was in 1887 to 1888, and this was attributed to Heinrich Hertz, the German physicist. He was investigating experiments from James Clerk Maxwell's theory of electromagnetic waves. So what did Hertz do? Hertz used a gap in two similar loops of wire using an induction coil to pass sufficient energy through one wire to make a spark jump in the other. Looking at the figure on the bottom right. When electric discharge spark jumped the air gap in one loop, a similar spark was generated in the second loop. The energy could have only been transformed by EM radiation. Hertz's transmitter was generating electromagnetic waves with a frequency in the radio range. Hertz then used a parabolic reflector to increase the strength of electromagnetic waves. He was producing and conducted further experiments to examine the properties of the waves by placing objects including metals in the path of waves. He was able to show that the wave properties of light, such as reflection, refraction, polarization, diffraction and interference, which was fundamental at that time to give us properties of EM waves. Hertz was able to make calculations of frequency of the waves based on the frequency of the induction coil, and conducted experiments to determine the wavelengths of the waves by reflecting the waves off a metal sheet and measuring the wavelength of the standing wave. This information then allowed him to calculate the velocity of waves and show that they were travelling at the speed of light. Hertz's observations provided convincing experiments proof that Maxwell's electromagnetic theory of light. He was also raised new questions about the nature of light and matter. Hertz also observed the spark was produced more readily when it was illuminated by UV light, and we know this phenomenon as a photoelectric effect, as both electricity and light were involved, but he failed to examine this phenomenon further. So Hertz did not have the opportunity to follow up on his ideas because he died at the age of 36. So in summary, why didn't he find the photoelectric effect? One, because of his age, and two, because of his experiments were lying along the lines of Maxwell's contribution with electromagnetic waves. So in summary, what did Hertz find? He found that electromagnetic waves could be generated, transmitted and received, which was the number one finding. He found that they travelled in straight lines, the waves that could be reflected, they could travel through non-conducting materials, they were absorbed by conducting materials, they travelled at the speed of light, which is 3 times 10 to the 8 meters per second. They were polarized, and they were electromagnetic transverse waves.